All right, so the second part, the powers of complex numbers, is what we're starting with. So we're going to use those last two formulas on your sheet, the De Moivre's theorem, where we will raise a complex number to a power. And then we'll also use formulas for nth roots, where we'll find all the real and imaginary roots of a number. All right, so the first part with the powers of a complex number, this first slide kind of takes you through how the formula comes about. So if you have a complex number in trigonometric form, which is just with the r cosine theta plus I sine theta, if you wanted to square that number, so to do z squared, right, you just do the complex number times the complex number. And so if you use that multiplication rule, you would do r times r, which would give you r squared, and then you would do theta plus theta, which would give you 2 theta, right? Or if you wanted to cube it, then you would do your r squared times r, and so on. And so what we find is that with De Moivre's theorem, well, it keeps going. So De Moivre's theorem tells us that if we have a complex number in trigonometric form, and we're raising it to the nth power, then the rule is we take our r value and raise it to the n, and we take the theta and we multiply it by n. And n is the power, right? The power that you're raising the z to. So power that you're raising your complex number. So if you were raising it to the 7th power, we would do r to the 7th, and we would do theta times 7. Right? And that's what that formula says on your formula sheet. So make sure that you see that that's on there. You don't have to have it memorized. All right, so here it says use De Moivre's theorem to figure out what 1 plus root 3i to the 12th is. So when we look at our formula sheets for raising a complex number to a power, so when it's in standard form like this, to raise it to the 12th without just using your calculator and getting a decimal, you would have to multiply it out 12 times. So 1 plus root 3i times 1 plus root 3i times 1 plus root 3i, which my guess is you don't really want to do that. Like, that's a lot. So what we could do then is to use De Moivre's theorem. To use the theorem, we need to put our a plus bi number into trig form. So what we just did in that first part of the chapter, we first have to get this into trig form, so that way we have an r and a theta. So your r value will be the square root of 1 squared plus root 3 squared. Or your r value will be the square root of 1 plus 3, which is 4. So r will equal 2. And then to find theta, we'll say the tangent of theta equals b over a, so root 3 over 1. If we were to look at our point is 1 root 3, which we know is in quadrant 1. So when does tangent equal the square root of 3 in quadrant 1? We would say when theta is at pi over 3. So our first step, just rewriting that complex number, we would say is 2 times the cosine of pi over 3 plus I sine pi over 3. And then what we're doing is we want to take that whole thing and raise it to the 12th power. And so when we raise that to the 12th, we'll take the r and raise it to the 12th. And then we take our theta and we multiply it by whatever the power was. So 2 to the 12th is a 4096. So you get 4096 times the cosine of 12 pi over 3, which is 4 pi, plus I sine 4 pi. So what this, I guess, kind of the equivalent here is if you were to plot the point 1 root 3 on your complex number system, right? You'd have 1 and root 3, so you'd be about right here, right? And so what happens then is when we convert it into this trig, your polar form or your trigonometric form works on this polar graph. So that kind of that map thing at the back of the classroom that has all those circles like the dartboard, the one that Derek ripped the other day, that one, right? That's a polar graph where each circle represents an R. So what happens here is if we were graphing this number on the polar graph or we're using our trig form, where R is 2, from the origin you would go out to the second circle, and then your theta is how far around you rotate on that circle. So then on that second circle, if I rotated around to pi over 3, I would get to the same place that number would be if I graphed it on a complex plane. So that's how those two things are tied together. All right, so do we feel okay with raising it to a power? Hopefully, raise R to a power, multiply by your power. Okay, so the next part is the roots of a complex number. So if you're going to pay attention to anything here, I need you to pay attention to this because there's a little bit that goes into this. There's some steps that you have to take, and the formula can be a little bit confusing. So to find your roots of a complex number, if we want to find n roots, or the nth roots, then that's how many solutions we're going to have. So if we have to find the 4th roots, then we're going to have 4 answers. And so again, your first step is still writing it in trig form, just rewriting your number in trigonometric form. But then to find our roots, our first root will come from taking the nth root of R, and then we'll have to figure out our theta. And then from there, all of our roots are equally spaced out around our circle. So I don't necessarily use the formula all the time. I think it just will logically probably make a little bit more sense to you. So let's go through the process of finding, in this case, find the 3 cube roots. So how many answers should we have? 3. Okay, so if we're talking about our steps, right, our step 1 is that we need to write this in trig form. All right, so write your complex number in trig form, which means we need to come up with our R value. So R will be the square root of 2 squared plus 2 squared, or the square root of 8. All right, and then your theta will be your tangent of theta will equal B over A. Again, though, let's make sure we're in the right quadrant. So negative 2, 2 is in quadrant 2. So tangent of theta will equal negative 1 in quadrant 2 when theta is at 3 pi over 4. Right, so our trig form, so our number in trig form is the square root of 8, or you could simplify to 2 root 2, times the cosine of 3 pi over 4 plus I sine 3 pi over 4. This is not one of your roots. So this is not an answer. This is just rewriting the problem in trig form so you can get to your answer. So once you're in trig form, then you can go on to your step 2, which we'll say step 2 is you need to find, in this case, the nth root of r. Right? Because if you look at your formula sheet, it tells you you have to do the nth root of r. So we're finding the cube root, so we have to do the cube root of the square root of 8. So what's the cube root of a square root? The 6th root? Right, this is the same thing as like saying 8 to the 1/2 to the 1/3. Right, it would be 8 to the 1/6. So our cube root of the square root of 8 is the 6th root of r. So if we're starting to write our roots, we're going to write them as the 0th root. That's your first one. We have the first root, and we have the second one. So these are going to be our 3 answers. They all have the same r value. So whatever you found for the nth root of r, that's our r value. So they're all going to have the 6th root of 8 as the r value. And this is that idea that if we were graphing this on a polar graph, right, they would all go out to 8 to the 1/6, which is like at 1.4. So if you had this polar graph out here, they would all be out on that like 1.5 circle. They'd all kind of be out right here. So if this green circle is like our 1.5, they're all going to fall on this circle, and they have to be equally spaced out. But we have to figure out where the first one happens. So your first one, if you go back to your trig form, right, this number is at 3 pi over 4. Right, so to find theta of your z sub 0 root, we're going to divide by n, whatever our n is. So do theta divided by n, and that will equal your z sub 0 root for your z sub 0. So in this case, we would say 3 pi over 4 divided by 3, which is like multiplying by 1/3. So our theta is going to start at pi over 4. So for this initial root, we would say cosine pi over 4 plus I sine pi over 4. And that step right there comes from your formula right here, where it tells you we're doing the nth root. And then that first one is your theta divided by n. That's where that is in the formula. And then to find your next roots, you're going to add 2 pi over n to get the rest of the roots. So that's how that formula works. So because they need to be equally spaced out, so our first one we said is at the 6 and at pi over 4. So our first root that we found is right there. And then the other two are going to be equally spaced out. And so since we have that whole circle, this whole thing is 2 pi, and we're splitting it into thirds, we have to add 2 pi over 3 to get the next root. So if I add 2 pi over 3, so here, I'm going to erase some of this stuff right here just because it's in my way. So to get my next root, to go from here to here, everything stays the same, but I just have to add 2 pi over 3. So I'm just taking this pi over 4 and I'm rotating it 2 pi over 3. So if you do pi over 4 plus 2 pi over 3, we need common denominators, right? So you would get 3 pi over 12 plus 4 pi over 12, which would give us 7 pi over 12. So our next one would be at cosine 7 pi over 12 plus I sine 7 pi over 12.
Wouldn't it be 8 pi over 12? Because you're multiplying the 2 by 4.
Oh gosh, yes. 8 pi over 12. So I'd be at 11 pi over 12. Good catch there, guys. We'll fix that. 11 pi over 12. And so visually what we found was at 11 pi over 12, so our next one is right there. And then to get to our last one, again, it's still equally spaced out, so what do you think you need to add to get to that next one? Same thing, still that 2 pi over 3. Again, that 2 pi is because that's the full circle, and the 3 is because you're splitting it into 3 roots. So if we had 5 roots that we were finding, we would add 2 pi over 5. If we had 7 roots, we would add 2 pi over 7. We're just moving it around, which if we're already over 12, right, this is the same thing as adding 8 pi over 12. So if you add 8 pi over 12, then we're now at cosine of 19 pi over 12 plus I sine 19 pi over 12. And that would be your third root. So these 3 answers, and we're just going to leave it in trig form. I'm not going to have you go back to standard form. So even if your homework says write it in standard form, just don't. Just leave it like that. And so your answers look like that. It looks like a big mess of answers there. But what you found was these 3 roots, and 19 pi over 12 would be a little bit past there, so it would kind of be over here. And so those 3 roots would all be equally spaced out around that circle. So on this one, we have to find the 6th roots of 1. So how many answers are we going to have? 6. And so your first step is to put it into trigonometric form. But even before that, it might help by writing it in standard form. So if we have 1, that means then we have 0i. So writing it in standard form. To write this in trig form, to find your r value, right, r will be the square root of 1 squared plus 0 squared. So we just get that r is 1. And then theta, we'll say the tangent of theta equals b over a. And remember that whenever your b or your a is on an axis, it's probably easiest just to think about if I were to graph the point 1, 0, where would it fall? And it would be right there at 0. So in this case, our theta is just going to equal 0. So we'll have 1 times the cosine of 0 plus I times the sine of 0. Oops, I wrote theta. It should just be 0. Right, so that's your trig form. And remember, though, we need 6 answers. So we need our z sub 0, 1, 2, 3, 4, and 5. Right, because 0 is really like our first one. All right, so to find your roots, remember your first step is to take the 6th root of r. R is 1, so the 6th root of 1 just equals 1. So all of our answers will have the same r value because that puts them all on that same circle. So they're all going to have an r value of 1. And then we have to figure out the theta. So remember, to find theta, we have to do our theta and divide it by 6. In this case, our theta is 0. So 0 divided by 6 is 0. So our first one is just going to be the same thing that we wrote before. And then remember, we need to equally space these out. So then this is thinking to yourself, okay, well, my whole circle is 2 pi. So what are you going to add? So you're going to add 2 pi divided by however many roots you want to find. So 2 pi divided by 6 to each theta. And 2 pi divided by 6 we'll say is pi over 3. So if we add pi over 3, then our next root is the cosine of pi over 3 plus I sine pi over 3. And then if I add another pi over 3, I'm at 2 pi over 3 plus I sine 2 pi over 3. And if you add another pi over 3, you're at 3 pi over 3, which is just pi. And then we're at 4 pi over 3. And then our last one would be 5 pi over 3. And if you kept going, you'd be at 6 pi over 3, which gets you back to that first root. Right, so really what we did here was we took this, our r was once we were on that first circle, and we said the roots were at all the pi over 3s. So we were at 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and we were at that 0, 1. So those were those 6 roots that we found.